Okay, so 13a we got there. 13 part B, we're going to be using that error piece. So let's start writing that. I know we wrote this yesterday. So it was r sub 2 of x is less than or equal to m over 3 factorial, right? And then absolute value of x minus 4 cubed. And it was where the third derivative, or absolute value of the third derivative, is less than or equal to m. Okay, and then we were going from 4 to 4.2, and this is what we had talked about yesterday. So if we're trying to get this to be absolute value of x minus 4, we have to subtract 4 from all of the pieces. So then we're going from 0, and x minus 4 is in the middle, and then we're going up to 0.2. So the absolute value of x minus 4 is always less than or equal to 0.2. Okay, so we got to there yesterday, right? Is that where we kind of stopped, and then you guys worked on your own, right?
Yeah.
Something's still going weird. So our next step here, we've got to find what our m value is. Did you guys do that part yet?
Yeah.
So our third derivative, what was our third derivative? Was it 3/8? Let me write it up here. X to the negative 5/2. Okay, so we're talking about, I think in our notes we did it more like this, where we moved that to the denominator. We had 3/8 and then 1 over x to the 5/2, right? Okay, so then we're looking at 4. And you guys used 4 or no? So we're finding the third derivative at 4 and the absolute value of it. So that, let me write it more like what we did in the notes here, just one sec. We end up subtracting 4 here because we're trying to get it to look like this part here, the absolute value of x minus 4, so we can plug in for the absolute value of x minus 4. And then the other thing we need to plug in is our m. And to plug in our m, we've got to use this part here to come up with what our m value is. So that's what we're going to work on now. But does that make sense, the subtracting 4 to get it this part here?
Yeah.
Okay. Yeah, but and that's typically what happens. 13's weird because they didn't center it. They went from 4 to 4. They went from 4 to 4.2, and the center was at 4. Typically, they make it so the interval is like the same on both sides of that center. They didn't in this one. So we get to here, and we want to write it as the absolute value of x minus 4. Isn't it true, though, that if it goes from 0 to 0.2, it's always smaller than or equal to 0.2? But if we tried to put something else over here, like, oh, let's do 0.1 and average them, that's not true anymore, you know? So you have to use the larger piece with that. It's not common that they would do that. This is the only problem I think it even happens in, so. I don't think that you'd see like something like that on your AP test, but you just have to realize, okay, I need absolute value of x minus 4. What is it always less than? It's always less than that 0.2 or equal to it at that endpoint. Okay? Okay, so I'm going to try to do the m more like how we did it in the notes here. So our third derivative is equal to this here. So we're going to talk about the absolute value of that third derivative. So I'll write that in here. So we just have 3, and I'll just keep it as 3/8 times 1 over x to the 5/2. And we're trying to find what it is less than or equal to. So we can just put m there to start with. We're always looking then back at this part here because we're talking about the x, not the x minus 4. So we're always looking at this side here. We've got x is greater than or equal to 4. So if I compare the 3 over 8 times 1 over x to the 5 halves, we'll fill in the blank here, and then we're going to have 3 over 8 times 1 over 4 to the 5 halves. And if x is the bigger one, and x is in the denominator, it's going to end up being the smaller piece there. Do you see that? So that always takes a moment, but we always take that left endpoint, and our x is bigger than that. That's what this says right here. And if our x is bigger than that, when we're comparing these two, if the x is the bigger part and it's in the denominator, that makes this fraction actually smaller. Okay? And then this is a number that we can type in our calculator, and what is that number? That's our m, right? And you could do it without your calculator, because this is really just the square root of 4 and then to the 5th power, but let's just use our calculator. So the book has our m being 3 over 8 times 2 to the 5th, and that's where that 256 comes from.
Yeah, I like calculate that.
Did you? Is that, yeah, so that's where your last part went wrong. So I'm just going to do 3 divided by the 256. So it's approximately, if you were not keeping it as a fraction, like 0.01171,875 type of a thing, right? So questions on the m part, because really getting this part is key, and getting this part is key, because once you have those two pieces, then we can just put them into here, and then we can finish the problem. But if you can't get those two pieces, that's where you're going to get stuck. Okay, so let's finish it here then. So our absolute value of r sub 2 of x is less than or equal to, and our m is this decimal or that fraction. I'll just leave it as the fraction, being I've got it there, over 3 factorial, which is 6. And then I'll leave it like this just for the moment. And then I can replace the x minus 4, the absolute value, with 0.2, because it's smaller than or equal to 0.2. So the 0.2 can go on this side then. An absolute value is positive, so we don't need an absolute value there anymore. And then this is just something I can type in my calculator. So I'm getting like 1.5625e negative 5. So if we move that decimal to the left 5 spots, I get like 0.000015 625 is what my calculator tells me there. And remember, if we're doing like a less than or equal to, because this could have been rounded at the end there, I'm not sure. Do I want to pick a bigger or a smaller number here? Bigger, but it doesn't have to be a lot bigger. So it can be 0.00001563. That would make sense, right? Or 626 if you're like, but you know. I would, or just, if you can't keep this as 6 and just truncate it though, right? You'd have to round that up to 7 if you went to that spot. So I'll just go with 0.00001563. So questions at all? And the book just left it like this because apparently that's like the exact answer. It wasn't rounded at the end. If you're not sure if it's rounded at the end, just round it up slightly. Okay. For your graphing part, for part C, you don't have to like write anything down for it. You're not even turning your homework in, but what you're doing is you're putting this into your, like your y1 type of a thing, and then you're putting your function, which was square root of x, into your y2, and then your interval would be like what you're really looking at from 4 to 4.2, and then you can look at the table or the graph. The graph is probably, I mean, look at this error. It's insanely tiny, right? So your graph, you're probably only going to see one thing on that interval, but if you look at the table, then you can look at those values, And at what spot would you probably want to look for your largest error? And this endpoint here, though, is that going to have an error at all? No, because it was centered at 4. So you'd really just want to look at 4.2 and see how much that error is. And this is the maximum error, okay? So whatever that difference is at 4.2, it should end up being less than this if we did it correct. Okay, so you can kind of check your answer that way. Obviously, you have the key in an email, so you can check your answer that way too and make sure that you're getting them right there. But, okay. Okay, so number 9, find the Taylor polynomial t sub 3 of x for the function centered at a, and then you're graphing the function and t sub 3 on the same screen. So we got to find our Taylor polynomial to the third one. Did you just try derivative type thing? Yeah, and the derivative here, you'd have to end up doing like a product rule, and it gets kind of messy. You could do it, you moved it down and try it. Oh, I gotcha. So you move this to the denominator and dig quotient. That's fine too. What I would do instead to try to come up with your Taylor polynomial is I would start with the Taylor polynomial for e to the x. Kind of like that quiz question, you know? So if you start with e to the x, it's 1 plus x squared over 2 factorial plus x cubed over 3 factorial and so on. Yeah, and sometimes it's just like way easier. And then I'm going to get e to the negative 2x by doing what? Yeah, substituting negative 2x in for the x's, so we get 1. And instead of plus x, it's minus 2x. This one will become positive because it's squared. And 2x is going to turn into actually what? When we square it. 4x still squared. Right, because we're just putting, well, it's a negative. So negative 2x, and we're squaring it in that spot. So the negative goes away, but it turns into 4x squared, and then the denominator is still 2, so we could simplify that. I don't know that we need more terms. What were we trying to get? Yeah, t sub 3, so we need to the third power. So same idea here, except for instead of squared, we're going to cube it, so we'll do that one. So it's going to be a minus and 8x cubed, yeah. And that's over what? 3 factorial or 6, right? And I'm just going to put the dot, dot, dot. And then we need to still do what with that? Multiply by x, because we got to do one more piece there. So x e to the negative 2x. So you just multiply everything here by x. So x minus 2x squared plus, this is 2x cubed. I just simplified the 4 divided by 2 there. And then multiply by x. So do I really need this one anymore? No, because it's a t sub 3, which means the third degree. And this would have probably, you know, that plus, or dot, dot, dot in the back. Because we're talking about what it actually equals, but when we're just finding our third one here, then we're just listing those. Okay? So take a look at that, see if you have questions. Okay, so for 17, we're trying to come up with our Taylor polynomial. So we're going to have to get some derivatives here, I suppose, to come up with these. So our function is just this, our first derivative. What's the derivative of secant? Okay, and if you just have them memorized, it's secant x, tangent x. Now, some people just have a lot of trouble with remembering those. You should memorize them. We'll have time to like memorize those, but I know some people go, oh, okay, I'm stuck, so I'm going to go, this is 1 over cosine, and then you could do like your quotient rule, and you can come up with an answer that's correct. This is just the kind of simplest form of it there. Okay, so we've got that piece there. Our second derivative is, so here we'd have to use product rule. So we'd leave secant x alone. And what's the derivative of tangent? Secant squared. And then, okay, so first times the derivative of the second, plus, and then the second. And derivative of secant is, again, secant tangent. So we can clean that up a little bit. I suppose a secant comes out of everything. I don't know if this will help things, but if we take a secant out, we're left with a secant squared x plus a tangent squared. And tangent squared. Trying to think if I can clean that up anymore. I don't really need more than the second derivative for part A, but aren't I going to need the third derivative for part B? So that's the part that we're going to end up needing it. And I suppose you could leave it like this and try to do it. Where my brain is going, I'm not sure if it's going to take us anywhere. Sometimes it doesn't. Like I have to start at the beginning with these ones because I can't memorize things. I mean, I can, but I just don't. Okay, so we have sine squared plus cosine squared is 1, and I'm trying to get it to tangent, so I'm going to divide everything by cosine squared. And a lot of you have this memorized because you're good students. Sine over cosine is tangent. Cosine over cosine is going to be 1, and 1 over cosine is secant squared. So you could replace this tangent squared with what? Secant squared x minus 1. So let's try it and see if it takes us anywhere, being everything else is in secant. Plus, and this is another secant squared x minus 1. So we could write that as 2 of the secant squared x. It's probably a little bit easier taking the derivative of this than that, right? You could put secant back in, sure. Yeah, you just have the general power there then, so that works. So let's put it back in there. So we got 2 secant cubed, and then minus secant. So that's our second derivative, and then you just need one more for part B, so you might as well do it now. And we'll probably stop there, and I'll let you, but you might not have any idea where to go in part B. That's not a big deal. We can do that tomorrow. So our derivative of this, you'd pull the 3 down, right? The cube down, it'll turn it into 6, and then it's secant what? Squared. But then don't forget that secant of x is your inside function here, right? So what's the derivative of secant? Secant tangent. And then minus, and derivative of secant again is secant tangent. And if you, you could leave it like that if you want to. I would probably factor out a secant x tangent x because it's in both of these chunks here. And that's probably what you'd get if you hadn't, if you'd done like the product rule. So this is 6 secant squared x minus 1 then. And then we'll go from there tomorrow. I'll save this so that we're not trying to come back to it.